Here's the LU factorization algorithm. L will store the steps on A, where A is reduced to echelon form, and U is just simply the echelon form of A. So now let's take a look at the this problem. How do we LU decompose this guy? So take a look at here. First of all, we want to zero the first, like these three entries. So in order for me to make this 0, I have to use my row 2 minus negative 2 times row 1. So this is the number that I need to record. So negative 2. So it goes to the corresponding entries in my matrix L. So that's my negative 2. So similarly, in order for me to eliminate this 2, I'll have to do row 3 minus 1 times row 2, right? So therefore, I know this is the next entry will be 1. Similarly, if I want to eliminate this negative 6, I have to use my row 4 and minus 3 times minus, actually it should be plus 3 times row 1, which is the same as minus negative 3 times row 1. Oops, there's a typo here. This is supposed to be row 1, right? So therefore, I know the next entry that I have should be negative 3. Okay, so that's how I determine the entries below this 1 in the first column in my matrix L. You just simply record these numbers. Now after the row operation, so please check each row. That's what you are supposed to get. So the next one I want to do is to eliminate this negative 9 to make it 0. So in order for me to do that, I need to do the following. So my row 3, right? Row 3 minus basically plus 3 times row 2, but I have to keep track of minus negative 3 row 2. I have to convert this to minus sign. And the next one to eliminate this 12, I have to use row 4 minus 4 row 2. So R4 minus 4 times row 2. And I need to record these numbers right here. These numbers. So therefore I have negative 3 and 4. So continue this process. The next step is to eliminate. So please check these two rows to make sure that they are correct. But these two rows come from these two row elementary operations. So the next step is to eliminate this 4. Now this is not too bad. We're just gonna say row 4 minus 2 times row 3, right? So therefore you would know this is 2. So we are done. This is your U because it's already echelon form. It's not reduced echelon form. It's just simply an echelon form. So this is my matrix U, and this is the matrix L. So you can check L times U is actually going to be equal to A. So this is how you find the L and U in the LU decomposition.